Welcome to this session. This is an overview on treatment and quality of water. First of all, what does safe drinking water means? Safe drinking water is which does not represent any significant risk to health over a lifetime of consumption, including different sensitivities that may occur between life stages. This definition says significant risk, not the absence of risk. Water is purified, but doesn't lack of other components completely. This means that chemical and biological components are diluted on water and must be within established levels to minimize risk. How could we determine that water is safe to drink? We must know the quality of water. Water quality is measured by specific characteristics: physical, chemical, microbiological, and radiological. Drinking water must be free from taste, odor, and color. This is a physical perception and it is subjective, but we won't drink water that doesn't have these characteristics. The real safe drinking water comes from these three characteristics: chemical, microbiological, and radiological. For example, the physical characteristics could be the turbidity and the color of water. Turbidity is also known as opacity and visually indicates the quantity of suspended solids. You can see here clear to murky samples of water. Which of these samples would you drink? In wastewater, color indicates wastewater age, like gray or black in anaerobic conditions. You can see here this black water, wastewater, is contaminated. Some examples for another characteristics like chemical characteristics of water quality are toxic inorganic substances. These toxic inorganic substances could be some metals, mineral-based compounds such as nitrates and asbestos. This could occur naturally in water, but also could be because of one human activity, and could be antimony, arsenic, barium, cadmium, copper, lead, and these are from some industries, and they're directly to the water bodies. Toxic organic substances could be carbon-based chemicals such as solvents and pesticides, which can get into water through runoff from the discharge of factories such as this. Radiological characteristics could be measured by different equipment, but in general the measurements are located in these three characteristics. After we measure those levels or those characteristics in water, we obtain two types of guideline values depending on the use. Could be for drinking water or water for industries. Then these guideline values we can use it for specific characteristics in water. For industries, we have three types of water: the inflow water that might come from towns water, underground bore water, or rivers, It came from different sources, but it must meet quality specifications because it's the water that flows into an industrial plant for use. The second type of water in an industry is wastewater, that is usually high contaminated and contains high levels of dissolved or suspended matter. This is the water that has been used by industries through industrial processes. So we have to treat it. If we treat this water, then we have the effluent water, which is the water that has received primary, secondary, or advanced treatment to reduce its pollution. So this effluent water goes directly to the body, natural water. So this is an example of the treatment plant. We have in here the steps of the treatment train, and in this example is for distribution of safe drinking water. So we have the resource, and we have to protect that resource. And then we have the first treatment, which is a primary treatment or per treatment. We have the solids in here, retained and removed, and then primary treatment including sedimentation, and then this type of filtration could be rapid, slow, through sand and membrane, and a primary disinfection, which is mainly by chlorine, and then the water is distributed. This is a typical treatment plan for the distribution of water to our homes. If we want to treat the water, we have to know which pollutants are in it, and for each pollutant we have a treatment, and then in here we have some of the most common pollutants. Suspended solids could be treated by sedimentation, that is going down the solids, and coagulation and flocculation. Another important pollutant to treat is dissolved organic matter, that this is treated in a advanced treatment after the secondary treatment in a biological treatments or absorption. Then the inorganic dissolved solids that we already mentioned, that these are commonly heavy metals, and the acids and alkalis, and the solid waste. This is another example for a treatment plant, and here we have the water entering, and then is an output of the domestic use, and then we have black water or gray water, which is contaminated. Then we have a mixture tank where we have the pre and primary treatment, and then we filter that, and you can see here that the secondary treatment is also used for the reuse or disposal in this scenario. How could we know the efficiency of treatment systems? We have in here two examples. Sedimentation, that we said that was secondary treatment. We have a time of residence, the time that the water flow is going to be in this process, 2 to 4 hours, and then we have a percentage that the solids removal, and this concept that we are going to see in further classes, that is a measurement also for the organic matter in the water flow. And we have another example that is flotation. In here the time of residence is lower, 5 to 30 minutes, but we have a better efficiency in solids removal. And that's for solids separation systems, but we have also biological treatment systems that like facultative ponds, biological filters, aeration ponds, activated sludge, and anaerobic digestion. If you can see the efficiency of those systems, the activated sludge and the aeration ponds are the most efficient in biological treatments. This is another example. In this case, we have wastewater, not safe drinking water. We have wastewater, so we have to do more process or more operations in the train of treatment. So wastewater enters, and then we have preliminary operations. We have to control the flow, to adjust the pH, and we have to cool the water to avoid any problems in further equipments. And we have in here solids elimination and thick solids discharge. So in this part we have a solids discharge, and then the water flows over here, and this is the solid separation. We have the primary treatment with this sedimentation, flotation, and filtration. Then we have another solid discharge in here, and then the water flows over here, and we have a biological treatment, and then another discharge of solids. And in here in biological treatments we could have aerobic or anaerobic systems, and then the water flows, and we have the advanced treatment. In here we are going to eliminate nitrogen and other metals that are difficult to eliminate, and then we have the effluent water. This water is going to be returned to their nature, so it has to be well treated. Another method to evaluate performance of process of treatment is the performance target using the log reduction values. So we have in here these numbers are the concentration of some contaminant, and this is pre-treatment and post-treatment, and we have in here this logarithm value. If you can see in here the formula. You just have to obtain the ratio of the concentrations. It could be any kind of unit, but it has to be consistent, the pre-treatment with the post-treatment units, and then you obtain the base 10 logarithm. So if concentration is unchanged by treatment, then we have in here a value of log reduction of 0, and it is also possible that the concentration of the contaminant increases, then we have the negative value. But if the contaminant is reduced, that is where we want, we have positive values here. and this indicates that the contaminant is reducing from our the flow of water. So we studied the basic concepts of treatment and quality of water, and we studied also the performance targets that can specify the amount of log reduction values and that should be achieved from certain kind of pathogens, and system assessment, operational monitoring and management and communication should be part of the verification for any water quality system. So you have to manage all those resources to obtain a specific water for the specific use. That's all.